Nuclear bombs are one of the most terrifying yet marvelous accomplishments in human scientific discovery. But how do they actually work? Let's start with the first two nuclear bombs. The little boy dropped on Hiroshima and the fat man dropped on Nagasaki. These two bombs ran exclusively on the nuclear fission reactions of two different isotopes. The little boy used uranium 235 and the fat man used plutonium 239. These two isotopes, if they reach a certain density called critical mass, will undergo fission chain reactions when bombarded with neutrons. When a neutron hits one of these nuclei, the nucleus will split, giving off a large amount of energy, as well as two new nuclei and some neutrons. Those neutrons will go on to the other nuclei in the reaction, causing a chain reaction that emits an immense amount of energy, causing a huge explosion. Now, to actually reach critical mass, the two bombs use different methods, starting with the little boy's gun-type structure. This means that a high explosive, such as dynamite or nitroglycerin, is used to send one half of the uranium core into the other, creating critical mass and a lot of energy for the reaction to occur. Meanwhile, the Fat Man used an implosion structure, which utilized high explosives in a circle around a plutonium core, compressing the core enough to create critical mass for the chain reaction to occur. Modern, more sophisticated nuclear bombs, called thermonuclear bombs, employ nuclear fission and hydrogen nuclear fusion. Hydrogen fusion utilizes two hydrogen isotopes, deuterium and tritium, which are hydrogen with one neutron and two neutrons, respectively. In the fusion reaction, these two ions combine and release a helium atom as well as a neutron with a freak ton of energy on it. Fusion reactions only really occur in the plasma state of matter, so there needs to be an immense amount of heat in the system already before the reactions occur. That's why thermonuclear bombs usually have two adjacent cores, the primary usually being an implosion-type plutonium core, with high explosives around it and a core of hydrogen isotopes to accelerate it, and the second being a hydrogen fusion core. The energy from the fission core's reactions is used to heat the hydrogen fusion core so that the reaction can occur. All of these individual fission and fusion reactions combine to create a fireball of several tens of millions of degrees in the same temperature range as the inner core of the sun. And that's the craziest part, at least to me, about all of this. It's just the fact that us, as humans, managed to harness the actual power of the sun. And what's not so surprising is that we used it to destroy each other in wars. Instead of destroying each other with this great power, we can use it for good. We can use nuclear fission and fusion, and I guess we have been using it, for nuclear energy, which is a sustainable source. Nuclear energy is a sustainable source of energy that does not pollute the environment nearly as much as coal, oil, or any other fossil fuel that pollutes our environment and the air. These powers can be used for good. We just have to use the right judgment.